is extra practice number 1 of building polynomial functions. So I have number 3 here to start. We're going to give a possible factorization or factored form of the polynomial and state what we think the degree is. All right, so we start with the roots. I have a root at -2, which means when I write the factor, it's going to be x plus 2. Now you need to think about multiplicity here. Because I bounce off the axis that has a multiplicity of 2. The next root is at -1, so my factor is going to be x plus 1. This multiplicity cuts straight through, so it has a multiplicity of 1. I don't have to write anything. I can put a 1 if I want to, though. The last root is at +1, so the factor will be x minus 1. Now, notice here that my graph comes down and flattens out at the axis, which means my graph has, or that root has a multiplicity of 3. The other thing you need to pay attention to when you write these equations is that your arrows are both on the bottom. They're both going down, which means that you have a negative leading coefficient. So you have to put a negative in front. The degree here would be 2, 3, 4, 5, 6. So degree 6. You can always check this answer to see if the picture looks the same by graphing in Desmos. All right, graph your factored form. Negative, x plus 2 squared times x plus 1 and x minus 1 cubed. That does look a whole lot like the picture that was on my paper. So I know that I wrote my factored form correctly. All right, I'm going to do number 4 here, which is a multiple choice question. This one seems more complicated than it is. It says, which of the following could be the graph of that polynomial? Now, one thing I noticed is that my degree is 4, highest exponent, which means the arrows have to go in the same direction. All those arrows are going up or down. They're both all going in the same direction, so that doesn't help. The leading coefficient here, it says is positive. There's no negative, so that means the arrows both have to go up. That allows me to eliminate choice D. The other thing I know about degree 4 polynomials is they can have 3 turning points. Well, the first graph has 1, 2, 3. That could be it. 1, 2, 3, still in the running. 1, 2, 3, 4, 5 turns. That's way too many. So C is not the answer. The last thing is I have to think, because these last graphs are pretty similar. Look at the last number. That's your y-intercept of the graph. The y-intercept there is negative, which means you have to cross the axis at a negative. The first graph crosses at a positive, so that can't be right. The choice has to be B. All right, 2 more. Number 6, you're going to write the standard form given the roots here. This is similar to some of the practice we did on your notes. Add a factor of x equals 5. In order to get to standard form, you have to write the factored form first. The factor for x equals 5 will be x minus 5. Here the 7 comes up in front of the x, write your factor. It'll be 7x, the opposite of -2, and then x minus 3. In order to put these into factored form, or standard form, I'm sorry, you need to multiply 2 together at a time. I always start on the right. That's just my preference. I'm going to leave the x minus 5 out in front. Don't lose it. And when I multiply here, I'll have 7x times x is 7x squared minus 21x plus 2x minus 6. Now to make things a little easier, I'm going to combine like terms. I'm going to make that into 7x squared minus 19x minus 6. And then I have the x minus 5 comes back down. Now I distribute this. I'm almost done. Distribute the x. X times 7x squared is 7x cubed minus 19x squared minus 6x. Now I distribute the -5. Minus 35x squared. -5 times -19 is positive 95x. And plus 30. Now to get standard form, you just combine like terms. X cubed is the only one, so 7x cubed. -19x squared minus 35x will be -54x squared. -6x and 95x is 89x, and then plus 30 on the end. The degree here, the highest exponent is 3. It's called cubic. That means you can have 2 terms. And the end behavior, you can graph this if you need, but because it's an odd degree, the arrows are going to go in opposite directions. It has a positive leading coefficient, so the arrows are going to have a positive trend. That means on the left, your arrow is going to go down towards negative infinity, and on the right, you're going to go up to positive infinity. You can always check your work, graph your factored and your standard form to either help you with the end behavior or to see if you did things correctly. Last one, number 8. We're going to write the standard form of this polynomial. First, you have to start with factored form. I have a root at -2, so that factor is going to be x plus 2. My next root is at 0. I like to put 0 out in front. That's just an x. Notice, though, that it bounces off the axis, so it's squared. And then my other root's at positive 2, so I have an x minus 2. Now, the other thing to notice, both arrows go down, which means I have a negative leading coefficient. I have to put that in front. Now I multiply to get standard form. I do the right 2 first. X times x is x squared minus 2x plus 2x minus 4. Now, when I do that, I should notice that those middle terms can cancel off, -2 and +2. That simplifies things. X squared minus 4 is what I get on the left, and negative x squared. So all I have to do is distribute that now. I'll get negative x squared times x squared is negative x to the 4th, and negative times a negative is plus 4x squared. If you want, you can check on Desmos that picture looks the same. Negative x to the 4th plus 4x squared. And that is what your picture looks like. Same roots and everything. Degree is 4. Means it has 3 terms. That's the max, and that's what the picture has. And behaviors are both going down towards negative infinity. All right, if you need help on the other problems, go ahead and ask your teacher for help or check the key on campus.